Free fall practice. So this is going to be much more challenging because now we have 4 different formulas to choose from, okay? So this is when the problem-solving process becomes extremely, extremely important. Okay, so question number 1, rock dropped from a tall building. How fast was it going after 3 seconds? Problem-solving process, write down every number with its units of measure. So 3.0 seconds, and that's the other number it gives us. Seconds measures time. Okay, but we do have some keywords here. 1, dropped. If something is dropped, that means there's an initial velocity of 0, and that object is going to be going down. It's going to be falling. If something falls, we have a negative 9.8 meters per second squared for gravity. Okay, so a lot of information is implied without actually giving you numbers. Then you have to specify what the question is asking for. What the question is asking for is extremely vital. So read the question carefully. A rock is dropped from the top of a tall building. How fast will it be going? It's a question of velocity. Well, we already have the initial velocity, so this must be our final velocity. Okay? Picking from our formulas, we have time, initial velocity, gravity, and we want final velocity. Well, this one solves for final velocity, and this one has final velocity and every other variable, but we want to solve for final velocity. So this is the formula we're going to use. Final velocity is the gravity multiplied by the change in time plus the initial velocity. There's our formula. Plug in our values. Final velocity, gravity, negative 9.8 multiplied by 3.0 for the time plus initial velocity of 0. Punch that into your calculator, and your calculator is going to say negative 29.4. All right, significant figures. We have 2 significant figures in our original numbers. So 2 significant figures in our answer. The 4 does not round up, so we get a negative 29 for our answer. Final velocity. Velocity is measured in meters per second. That is our answer, negative 29 meters per second. Now that negative, you might ask yourself, what's going on there? That just means that it's going down. That just tells us what direction it's going. So this is 29 meters per second, but it's going downward, which makes sense because it's falling. Okay, question number 2. How far will a dropped rock fall after 3 seconds? So again, problem-solving process, 3 seconds. Seconds measures time. Keyword, dropped. That tells us we have an initial velocity of 0. It's going to fall. So that gives us a negative 9.8 meters per second squared for gravity. Okay, if you notice, look at this very carefully. The data to start off question number 1 and the data to start off question number 2 is exactly the same. The only thing that's going to be different is the question. So it is super important you get the right question so you get the right formula. So this one asking for how far. Far is a question of displacement. Displacement equals, well, which formula for displacement? Well, we look at these 2 formulas, and they're very similar. This part right here on those 2 formulas is exactly the same, 1/2 g delta t squared. The only difference is that this formula has this vi times t. So initial velocity multiplied by time. Well, in this scenario, our initial velocity is 0. 0 multiplied by our time of 3, 0 times 3 is 0. 0 plus whatever this is the same thing as whatever that. This doesn't make any difference if our initial velocity is 0. It has no effect on your final answer. So we take this formula and we simplify it to this formula if the initial velocity equals 0. That's when we use that formula. So we just can avoid doing the excess time of taking 0, multiply whatever that is, getting 0 and adding it to that. We eliminate that to save ourselves a little time. We use the shortened version of the formula. So 1/2 g delta t squared. Okay, plugging in our numbers, delta d. The 1/2, put 0.5 in your calculator. Then we're going to multiply negative 9.8 for gravity, multiply 3.0 for time, and then square it. Now, order of operations, that square must happen first. Okay, so if you're going to do this piece by piece, you need to square that. 3 squared is 9, then multiply by the 9.8 and multiply by the 0.5. Or you can put it all into the calculator once, like I like to do. 0.5 multiplied by negative 9.8 multiplied by 3 squared. Calculator says negative 44.1. Okay, so significant figures, two significant figures, two significant figures, two significant figures are answered. The 1 does not round it up, so we get a negative 44. And displacement, units of measure for that, meters. Negative 44 meters. So again, what does this mean? It just means that this went the negative means that went 44 meters down. Okay? So dropping a rock, obviously off of a cliff, because it went really far down. Okay, question number 3. How much time must the rock fall to reach a velocity of negative 45 meters per second? Okay, so negative 45 meters per second. Okay, meters per second measures velocity. And it says to reach a velocity of implies that this is going to be the final velocity. Okay? Now, it says the rock, so we can casually assume it's the same rock that's been dropped and dropped and dropped. So if we're dealing with a dropped rock, then we can assume, then we know the initial velocity is 0. And because it's going to fall, we have a negative 9.8 meters per second squared for gravity. What is the question asking us to solve for? How much time? So delta t is the question. Well, if we look at our formulas, that solves for final velocity, that solves for displacement, that one solves for time. It has a final initial velocity and gravity. Final velocity, initial velocity, gravity, that's the formula we're going to use. So delta t equals the parentheses, final velocity minus initial velocity, close parentheses, divided by g. Plug your values in. Final velocity, negative 45 minus 0, close parentheses, divided by negative 9.8 for gravity. So a negative 45 minus 0 gives us a negative 45. A negative 45 divided by a negative 9.8, negative divided by negative gives us a positive. Calculator says 4.5918367, blah, 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 blah. Significant figures, just 2. So the 4 and the 5, the 9 is going to round the 5 up, so we get 4.6. We are solving for time, so units are seconds. Okay, question number 4. We have a negative 8.0 meters per second, and we have a 3.0 seconds. Seconds measures time, meters per second measures velocity. Okay? We are dealing, if you read the question carefully, the rock is thrown downward at the initial velocity. Oh, it clarifies there for us, actually. It tells us that negative 8 meters per second is our initial velocity. It tells us right there. Okay? And we know that it's falling because it's being thrown downward, so we have the negative 9.8 meters per second squared of gravity. And then what is the question asking us to solve for? So the rock is thrown down, initial velocity. What will its velocity be? So what is the velocity after 3 seconds falling? Okay, so the question is final velocity. So we have initial velocity, time, and gravity. Final velocity is our question. Gravity, time, initial velocity, and final velocity is the question. We're going to use that first formula. So final velocity is the gravity multiplied by the change in time plus the initial velocity. Plug in our values. Final velocity is negative 9.8 multiplied by 3.0 seconds plus a negative 8.0 meters per second. Plug that in. Don't forget your negative. So negative 9.8 multiplied by 3.0 plus negative 8.0 gives us, calculator says, negative 37.4. Okay? So significant figures. How many significant figures should our answer have? Well, we got 3 in our original numbers, so 3 it is. So 2 in our original numbers. 2 significant figures. The 4 does not round up, So negative 37, we're solving for velocity, so that's meters per second. Okay? Yeah. Backside. Remember, you need to be practicing these making an attempt to do them before you actually use this video to just check your answers. Okay. From the top of a cliff, a ball is thrown downward with an initial velocity of negative 15 meters per second. How far down will it have gone after 2.5 seconds? So we have a negative 15 meters per second, a 2.5 seconds. Seconds measures time. Meters per second measures velocity. Okay? It is thrown downward with a velocity of negative 15. Okay? It's not saying it has a velocity of negative 15 after so much time. It's saying it is thrown with that velocity. So that is going to be an initial velocity. We know that we're dealing with something that's falling, so gravity is involved, negative 9.8 meters per second squared for gravity. And now the question is asking us to solve for how far down. So the question is displacement. Our two formulas for displacement. This one we only use if the initial velocity equals 0. Is our initial velocity 0? No, it is not. So we're going to use this formula. Displacement equals initial velocity multiplied by the change in time plus 1/2 g delta t squared. Plugging in our values. So delta d equals initial velocity negative 15, don't forget the negative, multiplied by the time 2.5 seconds plus 0.5 multiplied by negative 9.8 for gravity multiplied by 2.5 squared. Don't forget the squared or you get the wrong answer. Again, order of operations, the cool thing is your calculator totally knows these order of operations. Okay, so you can totally just punch the whole thing into the calculator all at once. Check this out. Negative 15 multiplied by 2.5 plus, so these get multiplied before we do any addition, just like all these multiply before any addition. Okay, 0.5 multiplied by negative 9.8. Make sure it's negative, I didn't get the wrong answer. Multiplied by 2.5 squared. Don't forget the squared. So your calculator knows order of operations. We'll do that square first, and it's going to multiply, and then at the end, the last thing it's going to do is the addition. And we get, calculator says, negative 68.125. Significant figures. 2, 1 does not round up, negative 68. Displacement, measured in meters. We have a negative 68 meters. That negative just means it's 68 meters measured down. All right, so if I have a ball and I throw it with an initial velocity of 15 meters per second, exactly 2.5 seconds after I threw it, it will be going 68, it'll have gone 68 meters downward. There you go. All right, how fast will a falling ball be going after 2.5 seconds if it has an initial velocity of negative 15? Okay, so 2.5 seconds, measuring time, negative 15 meters per second, measuring velocity. Oh, and it clarifies there. It tells us that's the initial velocity. That's convenient. It's going to fall, so we have a negative 9.8 for gravity. Sorry, negative 9.8 meters per second squared for gravity. Okay, so if you notice, again, we started with the exact same information. A time of 2.5 seconds, an initial velocity of negative 15, gravity of negative 9.8. The only difference is the question. What's the question asking this time? How fast? So velocity, we already have the initial, so the final velocity is the question. Final velocity, the first formula solves for final velocity, so that's our formula. Final velocity equals gravity multiplied by the change in time plus the initial velocity. Plugging in our values. Final velocity equals negative 9.8 multiplied by 2.5 seconds plus negative 15. Make sure you don't take off that negative. Okay, so negative 9.8 multiplied by 2.5 plus the negative 15. Calculator says negative 39.5. Significant figures, we need two sig figs. So the 3 and the 9, the 5 rounds that 9 up. So significant figures, our answer is a negative 40 with the decimal point to emphasize that that has two significant figures. Units of measure, well, velocity is the variable we're solving for. Units of measure for velocity are meters per second. And so that just tells us that negative, that it's going down. All right, number 7, how much time does it take the ball with initial velocity of negative 15 meters per second to reach a final velocity of negative 51 meters per second? Okay, so initial velocity, 15 meters per second. It tells us right there. To reach a velocity, so that tells us it's going to be our final velocity. All right. The question doesn't specify as much as it should, but we're talking about, again, throwing the ball downward. Okay. So we're going to deal with the idea that's falling. So gravity is going to speed it up. It may start with this, but gravity is going to speed it up to that. So there's gravity. And the question is asking for what? How much time? So time is the question. Of all the formulas, only one of them solves for time, the last one there. So time is equal to the final velocity minus initial velocity, parentheses, divided by gravity. Plugging in our values. Our final velocity was negative 51 minus negative 15. Divide that by negative 9.8 of gravity. Now you can put it all in your calculator at once, but don't forget those negatives. Okay? So parentheses, negative 51 minus negative 15, close parentheses, divided by negative 9.8. Calculator says 3.67349, blah, blah, blah. Significant figures, 2, 3 and the 6. The 7 is going to round the 6 up, so we get 3.7. Solving for time, so we units of measure, seconds. Last one. A ball is dropped from the top of a cliff. It takes 26 seconds to reach the bottom of the cliff. How high is the cliff? 26 seconds measures time. We know that it is falling, so we have gravity of negative 9.8 meters per second squared. And keyword, dropped. So that tells us we have an initial velocity equal to 0. Not a lot of information. What's the question asking us to solve for? All right. It asks for how high is the cliff. Well, how high is the cliff versus how far down did it go is actually the same question. So if you think about this for just a moment, let's just draw a little picture here. Talk about a reference point. All right, you're up here and you drop a ball off a cliff. And it goes down. From your perspective, from your reference point, we're talking about the ball going down. So we're going to talk about a negative displacement. But what if you're down at the bottom of the cliff and you're looking up? And you're looking up and seeing what's happening up there. Okay? For you, that measurement is a positive displacement. But in the end, those two numbers are the same magnitude. That negative just tells us this going down, this one's going up. But it's the same number. So displacement is what we're really looking for. So the question is displacement. Correct formula, well, our initial velocity is 0, so we're going to use the shortened displacement formula. 1/2 g delta t squared. So that's going to be a 0.5 multiplied by negative 9.8 multiplied by a time of 26 seconds squared. Now notice 26 seconds. That's kind of a long time for something to be falling. I mean, we drop things off really tall buildings and it's only like 3 seconds or 4 seconds till it hits the ground. So 26 seconds, we're talking about like a really, 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 really high cliff. There's probably no cliffs that high here on planet Earth. Maybe on the edge of a canyon somewhere on Mars, but not here on Earth. At least not a sheer drop all the way down. Okay, so take that 0.5 into the calculator multiplied by negative 9.8 multiplied by 26 squared. 26 squared is a really big number. Okay. Calculator says negative 3312.4. Okay, so significant figures, I need 2 significant figures, 3. Okay, so 3,300 displacement, 3,300 meters. Now notice the negative. The negative we use if the reference point is the top of the cliff. All right, it would be positive if the reference point is the bottom of the cliff because it's going up from that reference point. Okay, so whether you choose to make it positive or negative, I don't care. Just be sure you know which reference point you're referring to based upon that positive or negative. And there you go. That is the entire worksheet. Hopefully it made sense.